recording. All right. Well, welcome everybody to today's Advanced Materials and Manufacturing Showcase, run by Deep Tech Showcase. For today's agenda, we're just going to have our opening remarks and introduce a panel, and then we'll jump into the pitches that comprise the sessions. Session 1 running until 2 p.m. Eastern, and then session 2 between 2 and 3 p.m. Eastern. So the vision of Deep Tech Showcase is to bring deep tech to the market by leveraging the power of the community. So what does that community consist of? Well, for starters, it consists of the startups that are developing these innovations, but it also consists of tech scouts from corporations and from the government who are seeking interesting partnership opportunities, potential strategic investments, solutions to some problems they may have, as well as investors who are seeking innovative solutions that they can invest in and get a good return on. So anchoring this ecosystem are monthly showcase pitch events separated by industry theme. As you may have noticed, this event's theme is advanced materials and manufacturing, but as you'll see in either the next slide or the following one, we have some other themed events. And at these events, the startups pitch to a panel and audience of tech scouts from the government, corporations, as well as investors. So aside from these pitch events, and in between them, we also do guided introductions for companies that work with us. So many of these stakeholders, whether they're investors looking for deal flow or tech scouts, just looking for innovative solutions that they might be able to leverage in their organizations, they are interested in connecting with us so that we can basically be a funnel for interesting technologies that they may be interested in. And what we do is we send some company profiles for these stakeholders to review. And if there's a mutual interest, we make an introduction and business often follows. And if not, we just continue sending other profiles of companies that may pique their interest. Now, some of our other showcase events that are coming up are the Energy Showcase, which will be on August 27th. There may be a decent amount of overlap, people interested in energy and interested in advanced materials, so highly recommend that many of you join that. And in September, on September 30th, we have the Autonomous Systems Showcase. So we'd love to have you join those as well. And now just a brief word from our sponsor, Eagle Point Funding, which is our parent company. We have Chaim Brenner, who's a business development manager, here to give a brief overview. Chaim?
Hey guys, welcome to the Advanced Materials Showcase. So as Brian said, my name is Chaim Brenner. I'm Biz Dev Manager here at Eagle Point Funding, which is kind of the umbrella organization that Deep Tech Showcase is a part of. Essentially, what Eagle Point Funding is we're grant and contract specialists, which is just a whole lot of words to say that we're grant consultants. Our scope of work breaks down to a few different parts, ETS really being a main focus of it. But essentially, we help deep tech companies navigate and win federal R&D funding opportunities. And we go about that in a few different ways. The first thing we do is we serve to aid in navigation and identification, meaning we're going to sift through all of the different alphabet soup of federal agencies that are offering different grant opportunities and help you find the grants, not only that are going to be most relevant for your technology, but that based on our experience, you're going to have the highest likelihood of win. From there, we get into the second part of what we do, which is the actual project management and grant writing, wherein we're going to start an onboarding process where we're learning everything we can about your tech, about your story. We're going to figure out how to best explain it, how to tell your story, how to present it in a way that is most accessible to the federal government. And then using that understanding over the course of what tends to be between a 9 to 18 month contract, we're going to offload most of the work of actually finding, filling out, and submitting the grants from you onto us, aiming to get to a point where you can essentially focus on your R&D, on developing your technology, on your company, and we tend to look at contracts over the course of 18 months, and we aim to submit between 15 to over 20 different grant opportunities. Obviously, that's not a limit. It's just what we tend to see ourselves being able to do. And within certain companies that we can meet certain requirements, we even do have set KPIs for the amount of money we're in. We use the Deep Tech Showcase to get you exposure to all the people that Brian spoke about before. And then once you've kind of gotten through the rest of that process, we can also help you access the different procurement opportunities, that'll help you actually get into the federal contracts, helping you turn that R&D and that tech into actual contracts with the federal government. If any of this seems like it could be relevant for your company, if it could be helpful for what you do, you can scan the QR code that's next to my picture to book a call. You can use the link that's next on the other side of the picture, and I'll even drop a link to my calendar in chat. And from there, I'm going to turn it back over to Brian to keep going with the web, with the show.
Awesome. All right. Thank you so much, Hyam. And yeah, highly recommend you book a call with him. Even if you just want to talk, it's a great person to speak with. So with that, so we're going to be jumping into our pitches just to let everybody know what the agenda will be. In case you didn't see it before, our first presentation is going to be with Superseed. And then we have Semplastics, Phase 3D, and Pure Blue Tech for the first session. And for the second session, we have Siren-Opt, Critical Innovations, Multi-Scale Systems, and Macrovay. So with that, I'm going to stop sharing and I'll have the panel introduce themselves briefly. Just say who you are, what organization you're from, and if you have any particular interests, something that particularly interests you in the advanced materials field or development that you think, or an application that you think is particularly interesting, as well as within the advanced manufacturing field, you could let us know. But if you don't happen to have one and are just overall interested in the topic, that's fine as well. Just giving you another option for part of your introduction. So with that, I'll start with Marissa Alma McGinnis.
Good morning. My name is Marissa Alma McGinnis, and I'm an investor. I'm with Golden Seeds, an angel group, R42, which is at the intersection of longevity and AI, and also with Blumberg Capital. And I'm happy to be here this morning. Thank you.
Awesome. Really happy to have you with us. Up next, we have Alex Hamilton.
Hi, good afternoon. Alex Hamilton, Craft Capital. Focus on dual use. The deeper the tech, the better. We range anywhere from $1 million startups all the way up to 100 million. Love to be help scale up the bleeding edge. Thank you for having me.
Awesome. Thank you so much for joining us, Alex. Up next, we have Hyundo Kwon.
Sorry about that. Great to be here. I'm Hyundo from Honda Accelerator Ventures. We are a CVC arm for Honda Motor. We look at advanced materials and manufacturing across sustainability, mobility, manufacturing, and robotics. And really excited to learn more about what technologies that we're going to meet today. So thanks for inviting us.
Awesome. Yeah, well, I'm excited as well. And thanks for joining. Up next, we have Jonathan Wu.
Hello, John from ITIC, the venture arm E3ITRI, which is one of the largest research organizations in Taiwan with about 6,000 to 7,000 researchers. And we focus mostly in semiconductor, materials, all sorts of deep tech, and happy to join today. Thank you.
Awesome. Really happy to have you with us. Up next, we have Julia DeVory.
Julia, I'm with Convergent Ventures. I'm an investor. We invest in what we call convergent technologies at the intersection of deep sciences and AI into mostly health and sustainability in industry, seed and Series A. Thanks for having me.
Awesome. Thank you so much for joining us. Up next, we have Carolina Lewandowska.
Hello, everyone. So this is Carolina from Starbeam Capital. We are a seed fund based in London that invests in deep tech hardware startups with a focus on the sustainable future of industry, so including manufacturing and new materials, and also AI infrastructure.
Awesome. Thank you so much for joining us. Up next, we have Katie Vasquez.
Hi, I'm with Calibrate Ventures. We are an early stage deep tech focused VC fund based in LA. So we do a lot of investments in robotics automation, AI, manufacturing, as well as some other categories.
Awesome. Really happy to have you with us today. Up next, we have Lisa from GC.
Hi, Lisa Dufresne, GC Ventures. We're the corporate venture arm of GC, which is Global Chemical. We make commodity chemicals and plastics. We have 2 biopolymer production facilities, and we also make acrylate resin coatings for paint and coatings through one of our wholly owned subsidiaries. So our investment thesis is largely around advanced materials for either coatings, polymers, green chemicals, or maybe areas we hadn't thought of. So thanks for having me. Looking forward to the pitches.
Well, thank you so much for joining us. Looking forward to it as well. Up next, we have Muzibul Khan. Oh, you're on mute.
Sorry, how about this now? You can hear me?
Yeah, we hear you.
Okay. Sorry about that. My name is Muzibul Khan. I am a technology scout working on behalf of Kyocera Corporate R&D and located in Silicon Valley. Our interest is mainly around decarbonization, battery, robotics, and advanced materials. So I'm looking forward to hearing a lot more about those. Thank you.
Awesome. Yeah, looking forward to it as well. Thanks for joining. Up next, we have Paul Garcia.
Hi, Paul Garcia. I'm contract support from Booz Allen for the Air Force Office of Energy Assurance. We work on what we call installation energy, and that is anything that is utility connected power and water. Thank you for inviting.
Awesome. Thank you so much for joining us. And up next, we have Ronnie Hobbs.
Good afternoon, everybody. Ronnie Hobbs. I work at Air Force Sustainment Center. We have the 3 major depots for the Air Force. We do all of the Air Force weapon systems from engines to exchangeables to commodities to aircraft. We do about $11 billion a year. We got about 42,000 employees spread across 26 different operating locations. So basically everything that everybody mentioned as far as investing, we procure or buy some of that in some form, whether it be robotics, AI, emerging technologies. We have to buy all of those capabilities to support the depots. So look forward to just hearing what you guys offer. Thank you.
Awesome. Thank you so much for joining us, Ronnie.
No problem.
Sure. Up next, we have Sergey Fedotov.
Hi, I'm Sergey, an investment manager with TEL Ventures. We are the corporate venture group for TEL, which stands for Tokyo Electron Limited. It's one of the largest manufacturers of semiconductor manufacturing equipment in the world. And we look for innovative materials and processes for semiconductor manufacturing. Thank you.
Awesome. Thank you so much for joining us. And up next, we have Todd Coulard.
Hey, thanks for having me. Todd Coulard. I'm a principal at Mark Ventures, where we invest in emerging defense technology, anywhere from seed to Series A.
Awesome. Thanks so much for joining us. So I believe that's it when it comes to the panel. If for some reason you're on the panel and I forgot to call on you because your name got lost in the list, please just send me a message and we'll get you introduced. But with that, we'll just dive into our pitches. And we have Super Seed here for the first pitch. So I'm going to enable screen share, and Sean, whenever you're ready, you can share your screen.
Okay. Let's see here. Can you see that?
Yes.
Perfect. All right. Hello, everyone. I'm Sean Peterson, CEO and co-founder of Superseed. What we do is pretty simple. We want to make better materials that are better for our environment and do it at a reasonable price. What we're tackling right now is finding a new way to give recycled plastics a second life through some materials engineering. And the first product that we're displacing is the most ubiquitous, and that is sheathing products, primarily structural sheathing products. So plywood, OSB, marine plywood, FRP panels, etc. Right now, the tariffs are probably the obvious reason why this is a pretty advantageous play for our current customers, just having something consistent. But as we're transitioning back to kind of reinvigorating American and domestic supply chains, we have to chop down weaker and weaker trees. That means they are going to last longer. That means they're going to be less, have to have more glues, more formaldehydes, more things holding them together that are toxic and ultimately don't solve the problem. And then there's obviously an environmental issue, right? There's going to be more plastic in our oceans than fish in the next 15 years. And at the same time, we don't need to harvest trees. If we're concerned about global warming, the best way to reduce the temperature of the earth is to keep our air conditioners in place, and those are old growth forests, right? All right, so how do we do it? 3 core pieces to our IP. So first starts with material science. So we're taking engineered plastics, we're taking recycled PIR, which typically has a pretty bad name, right? And then we're putting some things in our process in an internal master batching process where we granulate, we add additives that make this the first structurally extrusionable sheet that we have. We then do that at scale. So we use some AI to actually develop the molds that we create. We produce sheets in 1/2 inch, 5/8, and 3/4 inch thickness, and we can do that at any length. And we do that at rapid scale because we're extrusion molding these. This is the result. So side-by-side comparison to plywoods, marine plies, OSBs. It's going to beat it in just about every single aspect and be cost competitive. We are rot proof. It's not going to delaminate. It's going to be using the same tools to drop in. This truly is a structural one-to-one replacement for the status quo, except this is going to last longer. We're going to displace a lot of plastic from our landfills in the meantime. The market's significant. We're entering in a really straightforward, really strong value proposition resonating market right now, which is boat builders. We also just started working with our first RV and mobile home builders, as well as trailers and other specialty vehicles. And as we scale right now, we're looking at some DoD contracts where we're engineering these solutions because they're working really well in these incredibly tough industries, right? If you want to build something that's going to be hurricane proof on a house, test it on the floor of a pontoon boat. It's going to get hit by waves. People are going to jump on it. It's going to get wet. And that's an amazing use case for us. And that's what we're doing as we expand, is taking those use cases, finding new means that we can apply what we have today, but then using our internal ability to formulate new opportunities to create new solutions. And so right now, the next thing that's on our R&D agenda is creating a ballistic panel using our extrusion process. And so why we're crazy enough to do this and take on significant lumber manufacturers in the space is because we can operate incredibly nimbly at a fraction of the cost, and we can stand up a plant inside of 12 months. Right now, we take up about 1/100th of the space of the equivalent output of a lumber mill that makes plywood or OSB. So really CapEx efficient, pretty low risk in the balance sheet, and enables us to scale really quickly based on need. Our first plant right now is in Phoenix, where we can do about 80,000 sheets a year, 80,000 sheets a year there. That doubles next month. We had to increase that capacity. So our second extrusion line, which you can see here in this picture, will be arriving in a few weeks. And then we just secured our finance. We just closed our seed round, and we're building our second plant. Right now, that's tentatively going to be in Elkhart, Indiana, where 80% of the RV industry can be found, as well as a significant part of the recreational boat industry. And that'll about triple our capacity. So we'll be capable of about 500,000 sheets a year by the end of this time next year. And so we've got a team, all come from automotive backgrounds, electronics manufacturing backgrounds, and all in construction, also scaling plants, working with these types of groups and material science. We're a tight team here in Phoenix, and that's us. So I appreciate you listening in.
Awesome. Thanks so much, Sean. So with that, we're going to open the floor to questions. The way that we do this, and some of you who joined us before already know, we recommend you raise your virtual hand on Zoom. And the way you do that is you go to React on the bottom, on your control panel. If it's not immediately there, maybe with the 3 dots and more, but you could raise your hand, and then we'll call on you as you raise your hand. So we'll start with Sergey.
Thank you, Sean. Awesome technology. I love it. Just wanted to ask you about the end of lifetime for these panels. What happens? Does this enable circularity? Can you recycle them, rework them when you need to decommission them?
Yeah. So yes, you can recycle them. And one big piece of that is in servicing OEMs, they're trying to get to zero waste goals. So when they have trimmings for their offcuts, their CNCs, we ask them to Gaylord those. And then when we drop off our next order, we'll pick it up and take it back to our plant. We'll weigh it, we'll give them a rebate, and then we'll recycle that into new product. So they not only are getting zero waste, they're making a little bit of money on it, and we're getting some really good feedstock material back into our system.
Awesome. Thanks.
Great. We'll move on to Lisa.
Hi, Sean. So did you say that this was Second Life for plastics and that you're using recycled plastics? And if so, what kind? And where are you supplying?
We use a lot because we can dose and blend certain aspects, and we have different product formulations where we're extruding a cap layer and a core layer that are different. And so if it blends, we're using it. But to shoot right down the middle when we're buying, it's PIR, frac melt, PP.
Okay. And what kind of specs do you have to meet in order to use this for applications, say, in structural panels and building construction?
So it's more so that you have to constantly test, right? So that keeps our compliance means and our internal QA and our traceability really, really tight. But in order to get to that point, we had to go to the ICC, and it took us about 18 months to a year of going through approvals, going through various third-party labs, redundant third-party labs, and getting to a place where they can say, this is the first structural building material, building sheathing made out of recycled polymers. And so they had to develop their own AC criterion for that, which we're constantly tested against. And what that resulted in is structural passing for roof, wall, and floor sheathing in residential homes.
Okay, thank you.
Yeah.
Great. Ronnie?
Hey, Sean, this is Ronnie. Hey, so when you say you had kind of started working with DoD a little bit, can you tell me kind of what the use cases are there? And I say that more as like, I want to help you engage with the right people.
Please
but
do,
I want to
yeah.
hear what you've done with the DoD so far.
Yeah, absolutely. So we're doing a small little test build right now for some bee huts. We'd love to expand that out. There's a couple of values that we have today, which are, it's just a lower cost, higher strength sheathing material that is going to last longer. When you're putting up something quick, you are saving costs because there's no requirement for secondary processes, right? So you can put this down. It can be the roof sheathing material. You can seam tape the seams on it without the need to put something else that protects that roof itself, right? So there's cost savings just in how it is in saving steps in the process, and create something that lasts longer. Then what we're working on and some of the things that we're trying to get some grant funding for is the ballistics, which is what are the other things that we can innovate on? We've already shown that we can do some innovating stuff with our formulation simply because we're vertically integrated and we can extrude this and get to some results pretty quickly about what works and what doesn't. So the next thing we want to do is low-level ballistics, right? But for right now, the key things that we bring to the table are, we can offer a more, a stronger and something with a little bit more of a flex mod that works for, encasing, concrete walls and trying to eliminate spurlings and trying to have better waterproof structures. We can extrude at any length too without any extra cost. So if you're looking for continuous walls with no seams, if you're looking to just streamline build process, save some steps, we can do all that stuff today. So we're trying to get into applications where water, moisture are an issue and help strengthen those and speed up those build processes.
Hey, question for you real quick. Have you engaged with like the Air Force Civil Engineering Center and the civil engineering centers at the other services? Because that's really what's going to drive that requirement into the bases. So the
yeah, sorry.
Go ahead.
Just scratching the surface, right? And we just are scratching the surface in Maryland, and we'd love to expand that elsewhere. And we really would like to work with more CEs if we can.
Remember, CEs you have a CE at every single base. But like for the Air Force, we have one civil engineering center down at San Antonio that provides kind of enterprise guidance for every air base wing in the Air Force. So you really want to get them on board first, and then that can help drive it out to all the Air Force bases in our ecosystem, if that makes sense.
Excellent.
I can help connect you with
get connected there. Thank you. Thank you.
Yeah.
Awesome. And it looks like our last question is from Julia.
Hey, Sharon. Thanks for the presentation. I kind of have a two-part question. One, I'd love to know a little bit more about the potential downsides of plastics that you would expect, like long-term creep, thermal instability or expansion, I guess, UV stability, and then workability for the workers, right? Cutting, nailing, stuff like that. And then the second part is easy. It's just if you can talk a little bit more about your unit economics.
Yeah, sure. So I can answer those in reverse. So creep. Creep has been de minimis. We were still running load tests on samples we've had out there for 4 years, and it's going to be less than what we're seeing with wood. We were able to take some accelerated creep data and extrapolate that through our performance envelope. Most wood performance envelopes only go about 10 years, and we were able to push ours out to 50 years. So we feel much better about that. Thermal expansion, significantly mitigated with the addition of glass fiber, which is a big portion of some of our formulations. And what we'll find is that in thermal, we will expand less at our maximum temp than wood will expand when it is in 80% humidity. So you're going to see much less migration in that standpoint. As far as thermal rating, we need to be rated for 180-degree attics in Arizona, right, to pass our test. So structurally sound there. In terms of creep, as well as thermal expansion. So I think that settles all those questions. Unit economics, our BOM is basically 70% of our COGS, is 20% direct variable labor and 10% electricity. The cost comparison right now is we're 1-to-1 with marine plywood. And then we have some our used to formulation for construction that'll be about bring us to like 10% higher, 15% higher than high performance MDO overlay or performance roof sheathing, things like zip system. And the reason for that is we think we can earn it, right? So that's what we're shooting for. And then maintaining a 35% margin on that at scale.
Thanks a lot.
All right. Well, thank you so much, Sean. And if you would leave your contact information in the chat for people to know where to reach you at after this pitch, that'd be great. And
all right, doing that right now.
Awesome. Thanks. All
right, thanks everyone.
Thank you, Sean. So with that, we'll move on to our next pitch, which is some plastics. And
Everyone?
we have Josh here to pitch. So whenever you're ready.
Sure. All right. Can you see my screen and everything and hear me okay?
Yeah. Yeah.
All right, great. So I'm here to talk to you about a new product that we've discovered that we've been testing a lot on. It's called X-Foam. X-Foam is a hard ceramic, stiff, but not brittle foam that is easily machinable in its final state. So that what's exciting about that is, like, instead of having to make a bespoke piece and then get it to be just perfect, in the final state it can be machined, or if you're applying it, oh, this is a little bit too long, or I need an extra hole in it, you can just machine it, even with hand tools, CNCs, or anything. What's really special about it also is that it is stable in air from cryo up to 13 and in some cases 1400 degrees centigrade, which is up to 24 or 2500 degrees Fahrenheit. So it is a very wide range of temperatures that it's good. It's also 7 times lighter than water. One of the most spectacular things about it that we're very excited that we discovered is that this little slab of about a little less than 1 centimeter, about 3/8 of an inch of this X-Foam is able to keep this ice from melting, even though it's being hit from the bottom by a 2000 C propane blowtorch, and the ice does not melt. So the thermal conductivity of this material is something that was a little bit surprising to us and remarkable. We found with official thermal conductivity testing that it is only about 1.5 times as thermally conductive as air. So if you had nothing there in air, this would only let through 1.5 times as much heat as that. Only aerogels and ceramic blankets can meet or exceed that kind of thermal insulation value. But what I have here is that this stiff but not brittle ceramic is able to hold a lot of weight. What we show here with these concrete blocks being held up by two 2 by 1 inch pieces is only 1/10 of the compressive strength. I could actually then go stand on those concrete blocks and the ceramic foam would not crush. Here's something else that's really interesting. On a thermal shock situation, if we take some of this foam and we dip it into liquid nitrogen and let it sit in that liquid nitrogen, just taking it from room temperature, we show that when we dip it into cryo on this thermal shock test, we have 0 shedding, 0 cracking, 0 deformation. Take it directly into the propane blowtorch until it's glowing. And this is a shock test that we're getting of over 1000 C, not per minute, which is considered a very extreme shock test, 1000 C per second. Then we dip it right back into the liquid nitrogen and let it sit there. Having taken this back out of that, we then have a situation where we have no cracks, no shedding. I can tap it against the table. It appears to be untouched, unscathed, and none of the chemical or mechanical properties are degraded by that extreme that test right there. So we can also then pick it up immediately. You can see I have rivulets of cold coming off of this, but it's like those space shuttle tiles. And I used to work on the space shuttle with those tiles. And the rivulets of cold will still there. It has very little heat inertia. The heat capacity is extremely low for this due to its low density, some other chemical properties that it has. So it doesn't transmit heat, it doesn't hold on to heat, it just insulates against it while staying stiff and stable in air without being brittle. We also have a coating that I wanted to show you. We have the ability to deposit alumina onto the foam to hold it, to make it even a little bit stronger, but also just to make it so that you can do different things. That coating also doesn't have any CTE problems, coefficient thermal expansion. It expands it. It is so chemically bonded. It's not like a paint, it's chemically bonded. So we do that same test where we put in liquid nitrogen, we torch it, we stick it back in the liquid nitrogen immediately. Again, 1000 C per second shock tests. And what you're going to see here is that we don't get any cracking, delamination, or bubbles. I can tap on that or tap it against the steel table and the coating will stay on there, which gives us a lot of opportunities for a broader piece of use. Additionally, if we wanted to use this up in space or in a place that matters for vacuum applications, it does not outgas at all. We had E595 vacuum testing done. There was no mass change. There was no outgassing. It was everything passed at very good levels. And then I was like, I wanted to demonstrate somehow that this stuff is not brittle. So I shot it with a 22 LR. and it did not crack. And we're not claiming it can stop the bullets. It will stop a nice BB from a Red Ryder BB gun and catch it in less than an inch of material, but it will let things through. But it is very not brittle because it has some toughness to it. It'll bend. The strain of the material is a lot more than a regular ceramic, and so it'll hold together even under impact. So what are some of the use cases? Hopefully you're thinking of those in your head, and I don't even want to go through all of these because I don't want to stifle your imagination. But one of the things is like in rocketry, being the foam core of a different type of reusable rocket thermal insulation, cryo to fire. If you have a cold tank next to a hot thing, you don't have to use multiple materials because we can go negative 200 to 13 or 1400 degrees C without any compromise repeatedly. And then one of the other really interesting things, we can tune the porosity, thus the density, to a very tiny 50 micron pores all the way up to millimeter sized pores. We can tune that and have that. We can also change the electrical conductivity of this material from extremely insulating to very conductive, which means that it can be radar absorbing. And so it can be a radar absorbing, heat insulating material that is very stiff and machinable and extremely light, 1/7 the weight of water. And so, we think about stealth, we think about micrometeoroid impact insulation on satellites, we think about, oven furnace kilns, but we think of a lot of aerospace applications. And of course, in this presentation, since you'll be getting it, I put a screenshot of the spec sheet. Our team is made of several PhD technical experts, engineers, technicians, people that have commercialized over 50 products over their careers with 100 years of experience. We have people that have gone through and gotten the AS9001 certification multiple times. We have not done that yet for this because it's very new, but we have designed it and all of the processes that are now very repeatable for making this with AS9001 in mind. So we'll be getting that certification soon. And we're looking for people that are willing to scale and test with us, letters of not intent, but letters of interest and government partners to be like, hey, where might this fit? Who might be able to use it? And we come from a company that does a lot of materials research for a long time in the semiconductor and other industries. And I just want to thank you so much for your time.
Awesome. Well, thank you, Josh. And with that, we'll open up the floor to questions. Again, you just go on your React button and raise your hand virtually like Musibel has done. So we'll start with you, Musibel.
Oh, hi. Very fascinating product that you have developed. Could you tell us a little more about the radiation resistance? Can it withhold radiation?
Radiation in terms of like nuclear radiation?
Yes.
So we have not tested it for that. However, we have the ability to dope it with different things like a boron or a zirconia or even lithium that would likely allow us to do that. The polymer-derived ceramic technology that we have at the core of this, one of the things that it's extremely good at is encapsulating different metals and oxides and incorporating it into the framework. So if there was a particular, say, you wanted to capture alpha radiation or neutrons or, beta's trivial, but if you wanted to do something like radiation shielding, we could infiltrate. We've thought of infiltrating boron in it for other reasons, but we could do boron into it, for instance, and it would be a neutron absorber.
So the next question that I may have is, you talked about the radiation. Have you combined the radiation? If you do check into it, could you please check in radiation plus the heat, which could be, which may have a very interesting application. But I'd love to talk to you separately.
That'd be wonderful.
Okay, thank you very much. That's a very
It sounds like you have and I can imagine what you're talking about. That does sound really intriguing. We hadn't thought of going in the nuclear direction. I can just say that over the entire range, the negative 200 to 1400 or 1300 C, we don't see any chemical changes within it at all. And so it would hold on to whatever we inserted it to be radiation absorbing over that entire range stably.
Yeah, you may like to check more carefully about your material defects, micro defects. Maybe that will be very important since you are in research phase.
Yes, thank you very much.
Right. And we also have a question from Carolina.
Yes, hi. Very interesting. It's just, I understand you've been researching this. Have you actually, so where does the IP sit? Have you developed it in-house and have you currently patented it or secured it?
Yes, so we have patented this. We've patented some of the stuff that it's derived from, and we have patents pending on some of the processing of it. So we have we have the IP buttoned up. We're not in the research phase anymore of this, just to clarify, we're in the development commercialization phase with it. Obviously, there's still things that we can do, like adding nuclear absorbing materials. So we don't stop research, but we're at the commercialization phase right now where we already have customers and we're scaling up.
Okay, so that was my second part of that we work a lot with universities where they develop their obviously the solutions in a lab, but then they have problem with finding use cases. So, and you've mentioned there's several use cases for your product, but have you actually gone to a potential clients and they've expressed interest? And if so, what's your plan for mass manufacturing this product and cost for it?
Sure. So we've come to several people that we've come to with the thesis, and they confirmed like, oh yeah, you're absolutely right. It would be great for this. So anything from kiln makers, there's people that we're talking to. We're over in Orlando, Florida, so we are close to the Space Center. So there's a very large reusable rocket person that we're talking to right now that has confirmed that this is of high interest to them. That we have actually sold. I can't really talk about it, but we've done some stuff with them. And then there's another very large defense contractor that has made an order as well. So the scale up of this is very interesting. So we don't have any significant hazardous waste from this. We're able to make it using a situation that is very similar to bread making, followed up by a process that uses some higher temperature ovens, but not super high, right? So not 3,000 degrees or nothing near that. But that's the process. The inputs to this are all fully domestically sourced. Every ingredient can come from North America and does, and from America actually. And so we get them at a fairly low cost compared to anybody else selling some of the reticulated foams and other type. We're just much, much lower cost than them. But the testing that we would do is good. So we have not released a lot on our price points yet. A lot of it has to do with the quality levels needed for different application spaces.
Thank
But it
you.
won't break.
I have many more questions, but I'm not gonna hug the mic. Thank you very much.
All right,
Well, I look
great.
forward to hearing from you, Carolina.
Yeah, if you guys want to get in touch too, that could work after if you have more questions, Carolina. And just our last question, real quick, just because we're starting to get a bit pressed for time. Ronnie?
Hey, Josh, this is Ronnie. Hey, have you engaged with AFRL Materials Directorate already on this Air Force
No.
Research Laboratory? Okay, so when you say you have government customers, I'm not asking you to disclose it, but are you involved in any of the air vehicles that we're currently doing or not yet?
No.
Okay.
No, and it was a government contractor, not an actual government customer.
But would you be willing to sell directly to the government or work through us prime?
Yes, absolutely.
All right, thank you. I will try to connect you with the AFRL guys as well. Thank you.
Oh, thank you. That's very, I really appreciate it. Thank you so much for your kind questions.
All right, great. Well, thank you so much, Josh. If you would just leave your contact information in the chat so people know where to reach you, that would be wonderful. And with that, we'll move on to our next presentation, which is Phase 3D. We have Niall here to present.
Hey everyone, thanks for attending. I'm really excited to present. Thanks, Brian. So my name is Dr. Niall O'Dowd. I'm the president and CEO of Phase 3D. We're in the metal 3D printing space or additive manufacturing. We're focused on part qualification. So the main challenge that we're solving is the lack of quality control. And it's really the perfect time right now in the additive industry as everyone's transitioning from the prototyping aspects of 3D printing to production. We're seeing extreme exponential growth, but that growth is limited by part quality. There's high scrap rates, low confidence in part quality, and no clear path to qualification, which is extremely important for the most highly critical industries like aerospace, automotive, and defense. And what we see as the future is a method to 3D print metal parts on demand in a lights out facility with high confidence in part quality, as well as a born qualified paradigm where you have the part, you know its quality, and it's ready to be implemented into an aerospace application or the human body or energy, oil and gas situation. And, we have immense customer pull. We've been in the industry for about 4 years now. We have ARR customers, and we have lots of quotes from our installations of our technology. The industry is really crying out for quality inspection as well as certification. So we have a lot of customer pull, including lead scientists at NASA, GE Aerospace, the US Air Force. They're using 3D printing to address supply chain issues, lightweighting, strengthening applications, but without a way to qualify and certify part quality, it's really hindering the industry as a whole. So we've developed a technology called fringe inspection. And we believe that the way to solve this quality issue is to provide data about the quality of the printing process. So fringe inspection, it's an inspection technology that measures the printing process in real time. And it uses a camera and a projector. We use structured light scanning that scans every single layer of the printing process and finds defects and anomalies that are like 1/10 of the human hair in size. And we've developed 2 softwares to take this data and give our customers useful go, no-go actions, as well as data sets to help them prove part quality for their customers. So Fringe Operator creates a digital twin of the printing process, so customers can measure, identify defects, and improve their printing process in a repeatable and calibrated method. Then we're working on developing Fringe Qualification, which is a product to directly address the need for certification and qualification. These standards are just being developed now, but there's no commercial product that really satisfies the need for this qualification data sets. And so Phase 3D, our goal is to become the white glove part qualification, essentially the UL quality stamp for the additive manufacturing industry, using our real-time data and then post-inspection data like X-ray CT scans of the parts for our customers. And the most exciting ROI is really enabling this white glove qualification for AM. We have been working with multiple aerospace primes, Air Force, NASA, the Navy. We have 4 short-term targets for this technology. GE Aerospace, we've been working with them for a couple of years. They have 10 systems on order. We've done 3 installs at their production facility, as well as other aerospace primes. And really, this slide was presented by our GE Aerospace customer who has identified this enormous cost and lead time issue for getting these parts qualified. So suppliers can, serve the aerospace prime, serve the DoD in a time of need. The nice thing is that on the way to getting data sets ready for qualification and to be used for qualification, the ROI on just canceling defective parts before you waste a bunch of downstream cost and time printing is pretty large. And so we've proved this ROI out. And the nice thing is that once you install our system, you can get this cost savings by finding defects as early as possible during the printing process. So you don't have to spend time and money downstream doing post-processing, post-inspection, X-ray CT, which is a huge burden on the industry, and it's quite a large market. This is our addressable market. Right now, we've developed this fringe inspection product at our price point in the market. Total addressable market is $500 million. The fringe qualification product is where things really get interesting. We see that growing to almost $10 billion by 2030. And really, the drive for this market growth is as AM parts transition from prototypes, low rate production into aerospace and medical and automotive standard parts, we see a shift of the cost of qualification transitioning from specific experiments done by the manufacturers to software. And that software cost is going to be responsible for all of the quality assurance, all of the quality checking in the future by 2030. This is some information about our current status. Company's been profitable for the last few years. We're really interested in accelerating that growth. We're a market leader right now in providing this kind of inspection system. We actually have several partnerships with the main printer manufacturers to integrate our sensor directly into their 3D printing machines. So this kind of is a revenue forecast growth and our plan going forward. We're in a current 2 million fundraise right now. And this is some information about what we're planning on using our proceeds for. Really, we're in that transition period where we're looking to increase the quantity of sales by getting our own costs down to our customer, reducing our price, and then building more focus on integrating directly with the 3D printer manufacturers. So far, our business is based on retrofit model where the customer has the printer, they need quality inspection, and they paid us to develop the systems, install them, and support them on their existing printers. We're also going global. We have a reseller agreement with the automotive company in Japan that resells equipment. We have a reseller agreement with one of the 3D printer manufacturers in Germany, and we're on the verge of getting a reseller agreement with the main 3D printing company in Germany next year. So yeah, I really appreciate you listening and open for questions.
All right, great. So opening the floor to questions, if anybody has. Ronnie?
Yeah, hey, I got to run in a second, guys, but I did want to talk to you. So, as you can imagine, aerospace, I've met with 100 companies who are doing something similar. They all have a different process or software or capability. The biggest challenge, like you said, was qualification. Currently, we in the Air Force have capability to additively manufacture parts, but even within the Air Force, we can't get our program offices to approve for us to use those parts on the airplane. So a major, major challenge. However, there are a couple of teams, a joint additive manufacturer working group. There's another one that's being led by Divergent. I'm not sure if you're familiar with them. They are partnering with the Air Force to try to find a solution to this. But I would like to at least help you stay engaged in that because there's enough room for everybody, right? I mean, and if you have a better solution, you should be able to get that in front of the government as well. So after this, if we can correspond a little bit, I can engage you with our engineering director to make sure you're kind of tracking to that with us.
Great. Yeah, the Air Force, especially the Rapid Sustainment Office, has been a huge proponent. We really got our first tranche of R&D funding through AFRL, and we installed at the React Center at Tinker. And then we got another contract to install our system at Ellsworth, then Navy contracts, NASA contracts. So I don't know. Are you from the RSO, did you say?
No, so I'm Air Force Sustainment Center. The RSO was stood up to help us. So React is actually about 200 feet from me right now.
Oh, awesome.
I'm here at Tinker Air Force Base. So
okay, great.
It sounds like you're engaged, but the scaling is the issue because we cannot even get those parts approved to go on the airplane jet. So I just want to make it sounds like you're engaged. I can help you stay engaged, but if you already have the right contacts, that's helpful. I mean,
no, I would love that.
I
think, yeah, I mean, really the name of the game right now for us is transitioning from phase 2 to phase 3. And I think that all the sustainment arms, like we heard that Tinker has 10,000 parts on back order, and they get quotes from the original manufacturer, and it's a year, it's $1 million, and then Jason just prints them, in a week.
Yeah, but think about it. That's 10. Well, he might print one part a week, but that's 10,000 different people that you got to go to get approval for those parts. Because each part is managed by a different program office or an engineer for hydraulics or landing gear or structures. It's not like you can have one approval and then we can just print the part. So that's the longest pole in the tent for us. And we have 4-star level meetings of trying to justify why we can't use additively manufactured parts. And this is the next challenge. It's the qualification requirements, the in situ monitoring, the material specs. We're trying to work through that. Once we can break through that, it'll be a big market for companies like you guys.
we feel like the floodgates will really open when you can just prove part quality and the no questions asked kind of thing. Then everyone can print and support the DoD.
Yeah, agree, man. Well, you're connected with the right people, but just know I'm an ally and am here to help if you feel like you get stuck anywhere.
Great. I'll definitely reach out. Thanks, Ronnie. Yeah, thank you. And we'll have Marissa and then Lisa go real quick just so we could get in our last presentation of the session.
When were you founded?
I founded the company. It's based on my PhD in 2021. Then we've been non-dilutively funded, so we're raising our first diluted round.
Okay. And then what's the size of your team? How many people?
We have 7 full-time and about 6 part-time. So 2 mechanical engineers, 2 sales, 2 executives, 2 software developers, and then, legal support staff and a couple sales consultants.
Okay, thank you.
All right, perfect. Lisa, real quick.
Yeah, so familiar with the vision control jetting of polymers where you look at a layer and then you adjust in the next layer. But from what you're doing, can you help me understand what do you see? How long does it take to know what that means? Are you interrupting the print every layer to fix it, or is it sort of after the fact you say, in these 20 layers there was a defect?
It's a really good question. So almost every time we mention this technology, the conversation goes to closed loop control, where you find an anomaly, you determine if that anomaly is going to create a defect in the part, and then you correct for that anomaly. And so our system is different than vision-based approaches because we're actually inspecting the part and we're measuring it with real units. So like as you see here, these fringes, we actually build a 3D height map of every layer. And what we're doing is we're enabling the capability to solve for an anomaly or correct the part. And that's one of the big pushes. That's why the 3D printer OEMs are so interested in our technology, is they want to use our data to correct the part on the next layer, because you have immense capability to do that sort of thing with this digital manufacturing process. Currently, the state of the art is certify a build, make sure it's all good, don't touch anything, no matter what happens. And that's kind of the status quo right now. Aerospace companies, they have spent millions of dollars on qualification, qualifying the material, the printer, the process parameters. And so they're unable to change those things. So it's kind of like, in order to get the industry to a spot where you can trust the measurement, trust what the printer is doing to correct, you need to have that baseline measurement. And we're the only system that has calibrated unit-based data to do that. It's a really good question.
Great, thank you.
Awesome. Well, thank you so much, Niall. And if you'd leave your contact information in the chat so people know where to reach you, that would be wonderful. And with that, we'll move on to our next presentation, which is...
Great. Thanks, everyone.
Sure. Thank you. Our next presentation is Pure Blue Tech. So we'll have Ryan here pitch.
Excellent. Thank you, Brian. Can you hear me okay?
Yes.
Very good. I'm Ryan Vogel, CEO, founder of Pure Blue Tech. At Pure Blue Tech, our mission is to transform the economics and sustainability of treating and reusing water. This is essential for every industry, every manufacturer, and every branch of the DoD, as well as, of course, municipalities across the United States and the world. Now, we do this through a self-cleaning, self-preserving, intelligent membrane element that is interchangeable with existing membrane infrastructure. As you know, membranes are used in the manufacturing of literally every good and many services on planet Earth. Semiconductors, food and beverage, oil and gas, laptops, automotive, textiles, phones, just about everything uses water as an input or generates water as an output. Even data storage and AI ultimately run on water. The water and wastewater industries, about 750 billion globally. Membrane systems are essential within that, about 36 billion. Some estimates are more than 2 times higher than that. We're focused on the reverse osmosis membrane element. We can manufacture any other class of membranes, nanofiltration, ultrafiltration, and microfiltration. And within reverse osmosis, we are focused on high fouling feed waters. So as you may be familiar, while the membrane is separating the water from what's in the water, the phenomenon of fouling and scaling occurs. Things stick to that surface, clog the membrane filter. That's problem number one, endemic to all membrane elements. Problem number two is that these membrane elements are dumb mute materials. The operators have no idea what's happening inside of thousands of these membrane elements within a large system or facility. So fouling costs energy, chemical cleaning, shutdowns, reduced productivity, increased concentrate waste volume, and ultimately the membrane elements have to be replaced. Costs a lot of money. So at Pure Blue Tech, we've manufactured and developed with multiple patents a technology integrated RO element. We integrate ultrasound and nano imprints within that product, and we now also have monitoring capabilities, generating thousands of times more data as well from that. So we're directly improving the fluid dynamics at the surface of that membrane, keeping it clean and clear while generating all of that additional data, which allows for an AI opportunity to analyze, assess that data, and support better decision making. Last but not least, we are offering a recycling service for the first membrane element manufacturer to do that. So this is what one of the products looks like. These membrane elements go in and out of the system like a standard membrane element. They are interchangeable with existing elements. Phenomenon of fouling and scaling, you can see on the left, our membrane on the right stays clean and clear 75 to 90% better. This technology has been demonstrated in the field by Bureau of Reclamation, USBR, and others. Here you can see some of the data streams that we're able to generate, all of the critical information about the health state performance of each individual subcomponent in the entire system. This has never been possible before. So what all this means for the customers, they get more water, less waste, higher energy efficiency, and with the data streams, higher quality control, intelligence, the ability to optimize the entire system, the ability to automate water treatment and reuse. And what reduces is chemicals, downtime, labor, and waste. So 20 to 30% OpEx savings being the target, very fast payback period. You can see the industrial segment is the focus initially, higher margins and faster decisions. So we've been very fortunate. We've secured about $3.5 million in non-dilutive government grants and contracts, Army, EPA, USBR, as well as now moving fully into production and sales. We have more than $100 million of opportunities in the pipeline, some initial POs from major semiconductor manufacturer, Desalination Corporation of Trinidad and Tobago, and others. So we buy flat sheet membrane, we roll that state-of-the-art commercial membrane that's made by the major manufacturers, roll that with our technology to make the membrane element and sell that direct to the end users as well as through OEMs. The end game is to potentially partner with or sell the company to a major membrane element manufacturer, of which those membrane element manufacturers, we have built 4 out of the 5 major companies over the last 50 years. My team has about 300 years of experience combined in the industry, building the leading membrane products. Right now, I'm raising a $2.5 million convertible note. I have $1 million of that closed, $1.5 million available. Happy to share terms with you. Feel free to reach out to learn more about that. And this is really to set up the next scale of manufacturing. Our facility is based in Bellingham, Washington, and we can get up to about $20 million of product per year at that facility. And then this is leading to an $8 to $10 million Series A. So in summary, we solve the number 1 and number 2 problems with water treatment, desalination, and reuse membranes, and that's fouling and lack of data, multiple patents, and a growing portfolio. Team's done this multiple times before, full-scale manufacturing, supply chain in place, and significant traction. So happy to have a dialogue here and answer any questions.
Great. Thank you so much, Ryan. So with that, we will open the floor to questions. Again, if you have a question, just click on the React button on your control panel at the bottom of your screen to raise your hand virtually. If you don't see it, it might be under more, which is 3 dots. And once you raise your hand, we'll call on you in the order of hands raised. So I guess I could get the ball rolling. Ryan, do you want to expand on your semiconductor use cases or potential semiconductor use cases where you see your tech fitting into that space?
Yeah, so the semiconductor manufacturers use reverse osmosis membrane elements in 2 primary places. First is to purify, create ultra pure water to rinse semiconductors, the wafers, and then to treat and reuse that wastewater that then has a bunch of silica and organics, or alcohol and other things. So certain manufacturers of semiconductors are now actually achieving 95 to 100% water reuse. The big trend in society and industry right now is water recycling. Energy efficiency is still important, but water efficiency and water recycling is really right now the new goal that has emerged. So efficient reverse osmosis, where that surface of that membrane can stay clean and clear, will drive down their operating costs, save chemicals, save energy, produce more water, and produce less waste to achieve those goals, and secure their supply chain for water.
Awesome. Well, we have a question from Sergey.
Yeah, thanks. Brian, you actually took the question out of my mouth a little bit there. Ryan, I look forward to our meeting separately, but I just wanted to draw attention of you. I don't know if you've seen that SEMI, the industry organization for semiconductors, has an annual pitch competition for startups focusing on sustainable technologies. Looks like your company's technology would be a great fit for that. I can explain more later. I'll leave a link to that in the chat here, just in case. Thank you.
Great, thanks. And we have another question from Julia.
Ryan, good to see you. It's been a few years. I assume that you're mostly competing with the current membrane manufacturing companies right now. So please let me know if that's not true, if you can partner with them at the moment. But if you are a direct competitor now, what kind of scale of manufacturing do you need to reach to start becoming a potential M&A target for them? And then what are the capital costs associated with that?
Yeah, so the membrane manufacturers, again, of which my team and my board built 4 out of those 5 major manufacturing companies, they are our suppliers. So we do not make flat sheet membrane. We buy those from DuPont, LG, Toray, Veolia. The 5th one is Hydronautics. They are suppliers, so they actually see us as a means to get more of their flat sheet membrane into the field. And at the same time, we are competing with the membrane element sale. But they don't have any means to address fouling, scaling. They have no data. They have no AI. It's really old technology that they're working with. But their flat sheet membrane does what it does. Sorry for that. So the DuPont, LG, Veolia, they are looking at us as possible M&A target as we stand right now. So the goal is to scale production capacity. With our current facility, we can build between $15 to $20 million of product per year. And we already have the equipment and infrastructure to do that. So we don't need any new capital investment to get to that stage. But with the pipeline we have, we need to expand to a second facility. It'll be between 30 and 50,000 square feet. It'll be 4 production lines rather than 1 production line at our current facility. And that'll get us to that 75 to 100 million in revenue mark.
Awesome. Thank you.
All right. Well, that's all the time we have. But thank you so much, Ryan. And if you would just put your contact information in the chat so that people could know where to reach out to you, after you took off your slide with your contact info, that'd be great.
Thank you all very much.
Sure, thank you. And what we'll just do briefly, we'll just introduce some of the panelists who joined recently. So we have Chris Danick. You just introduce yourself briefly.
Yes, hi, nice to meet you. Chris, and I currently do a few different things, some independent consulting, work as a venture scout for Alumni Ventures, was with McKinsey for 8 years prior to that.
Awesome. Thank you so much for joining us. We also have Major Brian Vickers.
Hey, good afternoon, everyone. Major Brian Vickers. I'm with the Maryland Air National Guard. I'm the lead for our innovation cell. We do primarily mission support related innovations for the National Guard. So that would largely be things that don't hang off of a jet, which would be a lot of things that are being featured in this pitch presentation.
Awesome. Well, thanks so much for joining. And we also have Steve Sokolow.
Hi, it's Steve Sokoloff with Tech Council Ventures. We're a New Jersey-based fund with a regional mandate. So we're investing in the Mid-Atlantic region. We're an early stage generalist fund with interest in deep tech. About half the fund is healthcare, and the other half is split between clean tech and enterprise.
Great. Well, I'm really happy to have you with us today. And we also have Yvonne Lutsch.
Yes, and I hope, do you hear me, Brian?
Yes.
Okay, I had problems with my audio. Sorry about that. Yeah, I am with LAM Capital. We are the venture arm of LAM Research, one of the 5 largest semiconductor equipment manufacturers in the world. And we invest in startups in the whole semiconductor space. And this can be from materials. This can be like even, membrane technology for water purification. But this can also be like system and product. So we invest in hardware technology as well.
Great. Well, really happy with us. Just having some of the new panelists themselves, instead of all the panelists on here introduce themselves, just because we're running a few minutes behind. So some of the existing ones, feel free to introduce yourselves in the chat. And sorry, just we're running a bit behind schedule and want to try to keep things on track as much as possible. So our next pitch is with SirenOpt. And let's see if Jared's still here. All right, he seems to have dropped off briefly. So I'll just go ahead and have Critical Innovations pitch for the time being. We have, I believe, Ross here to pitch.
I'm here. Thanks.
Hi.
All right. Let me just share my screen. Great. Well, it's a pleasure to be here. Thank you guys for having me. My name is Ross Donaldson. I'm the president and CEO of Critical Innovations, and we're talking today about our technology, which is called Fully Qualified Manufacturing, also known as FQM, which is for the automated on-demand point-of-use production and qualification of mission-critical parts. Many of you are probably familiar with the problems of traditional manufacturing, which has a heavy logistical chain and a centralized, lots of logistics that goes along with that. It has problems for multiple reasons, long lead times, obsolete parts, especially when we're thinking about manufacture and maintenance for maintenance parts, for example, of aircraft or other aerospace components. In addition, there's additional problems from the Department of Defense standpoint. For example, if we think of future large-scale combat operations, ability to get those parts to the areas that are needed and in a rapid time. So our technology really focuses on making next generation manufacturing for maintenance a possibility. So we want to take it from the current paradigm, which is these centralized areas and a lot of logistics going on. For example, it's agnostic technology, but if we take, for example, a aircraft part that's needed, whether or not for the aircraft or for some other component at a base, under the current system, you have to get those parts from a centralized manufacturer and transport them to them. In the future, I think many people have talked about how an on-demand, decentralized, minimal logistics support system would be for multiple reasons much better from the current system. We have assured availability, you have on-demand production, it's scalable, and it's much more secure than the current system, especially for defense applications. So what are the problems with why don't we have that now? And so I think I'm sure most of you are familiar with additive manufacturing and how many of those key critical parts can be made already via additive manufacturing. There's multiple examples in the aerospace industry. A couple here are listed. But at the moment, although those parts can be made from additive manufacturing, also known as 3D printing, and those additive manufacturing devices themselves can be easily put in a distributed manner. The problem is that having those parts just come out isn't the full part. There's still a major gap in being able to use a part that came out of an additive manufacturing machine and put it directly into an aircraft, for example. And that key problem actually comes down to quality. There's a bunch of regulations and requirements for critical parts under, for example, AS 9100, and just printing out a part, and then nobody is in reality going to just go and use that part without knowing that it meets the quality standards as part of that quality process that's already baked into how those components are made. So what are those regulatory requirements? So this goes over how a normal part is made. You design it, you manufacture it. But then what happens in addition to that manufacturing part? And that manufacturing part is already in many ways being transferred from classic injection molding or other older machining technologies to additive manufacturing. But also what happens to a normal part, it then gets inspected according to a whole bunch of requirements for that particular part before it's going to be rationally used as any kind of critical part, either for an aircraft or for other missile systems or really any parts that fall under a strict quality system. Current technology requires a quality inspector or engineer at a central location after that part comes out. For example, even if you 3D print a part currently, still at that central location, you need the inspector to look at it, to test it, to make sure it meets all of those quality metrics before it can then go on. So we haven't really gotten out, although we've improved our manufacturing ability to kind of the modern age, we haven't really improved our inspection capability to allow that distributed process that we want. So fully qualified manufacturing is an automated on-demand point of use production and qualification system. It's agnostic to the actual type of 3D printing, although our initial devices are based on specific 3D printing technologies. The system itself can really be used for multiple different kinds. And the idea is that in the end, you have this is just a schematic example of a vending machine type system that is in distributed locations that not only can print out that 3D used additive manufacturing to make that part that's needed for that critical maintenance to get the aircraft or other system back up and online. But in addition to making it, it also qualifies that part. And that's the key gap that FQM fits into. And that is not existing amongst the current technologies. So this, of course, allows increased maintenance capabilities, reduce logistical and storage burdens, depot level maintenance facilities and operating bases and remote airfields, and then reduces all of those problems that come from not having those parts in the time of need. So how does the system work? So in addition to having, for those of you that are familiar with how 3D printing works, which is kind of widely known, you got CAD files, and that tells you how you're going to print your device, right? But that kind of file by itself is not sufficient to then also do the quality component that we're talking about. So our system has built up an additional software that looks at the inspection and testing requirements, and there's a whole bunch of process that goes into getting this filed, determining what those inspection and testing requirements are for each particular part, and then varies based on parts. So some parts can need to be stronger, some parts need to be a particular color, some parts need to have a durometer in a particular area that's different, or critical dimensions. And so those go all into that initial file that goes along with the CAD file. Then as the system works, it goes through, it really mirrors the process of a quality process that happens under AS 9100 already. So it has pre-process qualifications of the machine, in-process qualifications in quality assurance as that print is being made, along with the additive manufacturing, and then post-process inspection and testing as well. That then comes out with a final report for that part and a fully qualified part. Additionally, as required by those quality systems, we have 100% data persistence throughout, so that you can really track and that part fits into what's already the standard quality systems that are required. And so in the end, it delivers a product that's certified and ready to use at the completion of production without need for further quality inspections or manual intervention. So you don't need to be at the central location. We can finally be decentralized to make those parts. So here's an example, a little bit a more concrete example of that same thing, of just a particular widget. So we've got pre-processed materials and environmental inspection. So essentially, in a normal 3D printer, we have a whole bunch of additional added sensors for all components of it, so that we can make sure that the process is going according to the plan and those quality metrics that are in with the CAD file requirements. Then we have production of it with a whole bunch of in-process inspection as well, with integrated scanners and other sensors. And then as we get out, we have post-production inspection and testing, and then an automated qualification analysis. And then this is kind of one of the most important parts, is that it delivers a product that's certified and ready to use, or just as importantly, and what is not available from current technology, it rejects and quarantines the uncertified product. So at the end, if you imagine that vending machine type machine, it's only spitting out parts that are qualified, and importantly, not spitting out parts that are not qualified. And so those never get into the system and can't be used. So far, we've had a lot of traction on this. We've had a $1.7 million SBIR award from the U.S. Space Force, and also $2.9 million from the U.S. Army, focused on using the same system but for medical applications, which have very similar quality requirements. We've had a bunch of interest from other agencies as well. Overall, our company has worked on more than 50 different DoD awards, including from the Army, Air Force, Navy, Space Force, and have multiple DARPA awards currently as well. Our roadmap, what we're seeking at the moment, we already have a SBIR that we previously worked on. We have matching funds from that Army part. We're at the moment looking for Department of Air Force support, both the customer and end user, for an upcoming TAC-FI submission. And that's our primary ask at the moment. Our team has a great, kind of very unique expertise of both engineering innovation, government and contract expertise, and quality standards. And so that makes it very unique for this type of machine and technology to bring that forward. So, please feel free to reach out to me if you have any questions, and I'm happy to take questions now as well.
Awesome. Thank you so much, Ross. So opening the floor to questions. Again, if anybody has a question, you click on the React button on your control panel at the bottom and raise your hand virtually, as Chris has done. You may see the React right on the bottom of your screen, but if not, it would be under More, which is 3 dots, and there's More. So we'll start with Chris.
A couple things, Ross. First, just on the capability side, what are the limits on the size of the parts and the materials that you can use in this process?
Yeah, so that's a great question. So essentially, the FQM system is agnostic to, it's an add-on to existing additive manufacturing technologies. So really, it's however big the bet is on the current technology you want to integrate it with. So as you guys are probably familiar, there are giant beds and huge parts that can be made with current additive manufacturing technology, and then there's smaller ones as well. We've purposely made our system kind of agnostic to those other systems, so it's kind of an add-on to an existing system with the sensors and so forth, and then a big software component that goes along with that.
Okay, great. Second question is, what's your estimate of the potential size of the market? And I don't necessarily mean that in dollars, but what percentage of this whole spare parts and logistics train do you think this can actually address?
Well, I think it can address a huge part. It depends on if we're talking about in the shorter or the longer term. I think our initial goal is to focus on those key parts that that we kind of know from a maintenance perspective are frequently broken and having a difficult time to get those parts. But in the bigger picture, I think what we would imagine is there's one part that's the distributed production that we're looking at. But in the end, this saves so much time. So, we here at Critical Innovations have other lines where we're ourselves making critical parts for different types of projects. Even just in our own setting as a manufacturer, and this is actually how this project started up, it saves time and money just under normal manufacturing, because right now this is a whole bunch of people, even at the centralized manufacturing, that you're having to spend. So our initial pitch is for the distributed functions, because that's what makes the system special. But in the end, I think you're going to find that under any kind of parts that have a very high quality standard, that this is going to become kind of the standard for all of them. So I think it has a very large total market in the end.
Okay, but you haven't tried to quantify this at all yet.
No, not particular for the manufacturing market part.
Okay. Thanks.
All right, great. Go for another question if anybody has one. I'll just give it a second. But if not, Ross, please just leave your contact information in the chat so people know where to reach you at. And thank you for your pitch. And with that, we'll move on to our next pitch, which is multi-scale systems. And we have Jesse here to present.
Well, hello. Let's see if I can get this screen share going. How's the audio quality? Can you hear me all right?
Great. Yeah.
Okay. And see the slide all right?
Yes.
All right. Thank you for confirming. All right. So good morning, good afternoon, good evening. I don't know what time zone everyone's in. My name is Jesse. I am a physicist by training, but I'm also the CEO here at Multiscale Systems and Hybrid CNC Parts. We are a vertically integrated set of companies as part of the Multiscale group. And today I want to share with you guys a little bit of what we're doing on the advanced materials and manufacturing. So the world that we play in is that we don't sell equipment. We don't sell, we're not an OEM in that regard. We make parts. And so a lot of the interactions that we have and a lot of the pain points that we hear is that there are a critical lack of suppliers that are comfortable, capable of working with advanced materials or advanced manufacturing technologies. Partially because the more established companies won't take on low volume projects, but also because the smaller job shop type places just aren't making the necessary investments in coming up the learning curve of how to get comfortable and familiar and really develop a niche expertise in these advanced materials and manufacturing processes. And what that creates is a barrier for larger companies to be able to access the benefits of advanced materials that are going to be required for the next generation applications, whether it be operating harsher temperatures, higher temperatures, harsher chemistries, driving out costs where needed, etc. And so for us, when we're talking about advanced materials in manufacturing, we're talking about a hybrid manufacturing process where in one motion control system, in one machine, we both additively manufacture, precision mill, and finish metal parts. And so I know there's been some decent amount of discussion here on metal additive during the event. I want to distinguish the work that we're doing to highlight that, again, we're not selling the equipment, we make the parts, but our feedstocks aren't powder, they're metal wire. And so as a result, we're able to actually look at a lot of the existing wire, laser, DED standards, like AMS 7010, AWSD 20, and basically grab onto those existing standards for qualification when we do our additive builds. And then you can see here in the picture what some of these finished parts look like. Know if this shows clearly, but like this is a 3D printed bearing made out of Inconel, which is a nickel super alloy. So, you know, kind of as I said, Multiscale Systems, a member of this Multiscale group, larger, more vertically integrated entity. And when you engage with us on the Multiscale Systems side, you're really engaging with a team of nerds that are really involved in the engineering, the design, the low volume, high complexity. And what we offer our customers is the ability to come to our doors to work with us on the initial builds, the pilot projects. And when everyone is happy and parts are qualified, then we're able to do our sister company, Hybrid CNC Parts, and it allows us to transfer that knowledge under one roof into the production team where we can supply components at the appropriate scale. So what you're getting when you work with us is this experience to be able to leverage our expertise that we've built up on how to make parts with the benefits of metal additive manufacturing through this hybrid process and get a full supply chain solution. We work, like I say, with wire feedstock, so specifically MIG wire. MIG wire comes with certs, they're widely available, there's lots of code cases. We've qualified a number of different materials, including Inconel, 718, Hastelloy, Stellite, a number of different stainless steels, mild steels, tool steels. They're just the ones that are coming off the top of my head, but you know, we have a full list available if anyone's interested. And I think for us, when we're talking about these materials, like if you are in the right niches and Inconel means something to you, that's great. And you know, we can bring that and unlock the barriers to access those materials for those applications. In addition, we also have some proprietary work that we've been doing where we're building with our machines the ability to do multiple materials in one part. And so we're actually compositing multiple alloys into a single piece to be able to clad, say, a hardened tool steel or hardened stellite onto on an interior surface of something else that's maybe more mild and easier to machine. And so this compositing process that builds multi-material parts really is, again, enabled by our expertise in this hybrid manufacturing process. We are, as I say, we have this two sides of the coin where we're engineers and nerds on one side and production and operators on the other. So we really like to get sleeves up and involved on the design side early on. That allows us to be able to bring the benefits of a hybrid manufacturing process and validate a program that once it gets qualified with materials testing, whether that be mechanical, which we do in-house, composition, which we have partners for, and get that process really locked in, that program's locked down. We just basically turn around to the guy at the next desk and say, all right, call the program and run 100 parts. We got to ship the next week and a half. Unlike a lot of powder metal additive, we're able to produce quite fast. We're able to build parts at about £1 an hour. And so if you have a 50-pound part, that's a 50-pound additive job. And then the precision milling, that comes in right in there in the machine. So you get that add and subtract ready to go. This allows us to offer a lot of support for one-on-one type projects, pilot builds, a lot of high customization. So if you're thinking about tooling or other mission critical components that are being developed for extreme environments, those are really good spots for us to play in. There's also some use cases for this for repair and refurbishment, which I think is interesting and merits more discussion, because that also kind of fits this one-of-one type notion for what this technology is really well designed for. But just to give you a couple of use case examples or pictures, like this is one of the ones we've been working on recently, where we have a multi-material part where the interior this is Inconel. The exterior is mild steel, and it's been designed with an interior profile that allows the benefits of a nickel superalloy on that interior bore with a mild steel exterior, which is really easy to machine. So these blanks have been designed to allow other people to take this and then go and finish it for their applications. So they're not cutting hard Inconel. They're not relying on additional expertise. It's just mild steel, while the finished part gets the benefit of those materials. And for us, these applications have looked like Gen 4 molten sodium reactors. We've done this for NASA, we've done it for DOE, we've done it for commercial reactors, we've done it for general manufacturing, another number of other both government and private sector customers. Valves, another interesting use case. One of the ones that we worked on not too long ago. This was one where a customer needed us to reverse engineer and then make a one-of-one. So here you see the interior design of this part, admirably built. We clad an interior seat with a wear-resistant alloy to allow this thing to perform the necessary environment. And this is one of those things where the supplier has a monopoly, and lead times were 6 months or more. And for us to take one, reverse engineer in a week, run a validation run of a few parts, send it out for customer qualification, and then we're on to the races. So for us, we have this real collaborative design for manufacturing, design for additive manufacturing on the engineering side, and then on the production side, we've gotten our ISO 9001, AS9100 in order. We've got our cybersecurity boxes checked, and we're really in a good, strong position to be that partner to unlock the benefits of additive manufacturing. So if you have a problem that doesn't have an easy solution, we'd love to hear about it. If you're more plugged into the supply chain side where you have tough challenges, you're not able to get suppliers, we're here to raise our hand. If you're more on the investment side and you have stakeholders that you're connected to that benefit from the pilot project, our doors are open to bring these capabilities to the commercial market. So with that, I'll thank you for your time. I'll be happy to take any questions.
All right, great. Thank you so much, Jesse. So with that, we'll open the floor to questions. If anybody has a question, just raise your hand virtually on Zoom, and we'll call you in the order of hands raised. Lisa?
Hi, Jesse. Thanks for that presentation. So my question sort of comes from a 3D printing angle. Do your customers know what they want to make, and then you figure out how and at what cost to make it? Or do you have a capability that you have to go out and pitch to people and say, hey, maybe you wanted this part, you didn't think anyone can make it, maybe we can make it? Because they're two different business models, and the second one's a lot harder to find customers than the first. So I'm just a little sort of unclear about how that works.
We have two customer journeys. When customers come in on the multi-scale system side, they come in for engineering and R&D. They have a concept, an idea, some draft, and then we work with them to finalize it and get that prototype designed and built. On the hybrid CNC parts, which HCP, that's our CNC shop, that's just parts made to print. And so if customers know what they want made, if they want something in precision machined, we can do that. If they don't know what they want, if they want to enter into a longer development cycle, we can also do it. But because it's one vertically integrated team and we're all under one roof and we're all plugged into each other, our engineers have really gotten good at the DFM, I should say DFHM, design for hybrid manufacturing, to be able to help our customers bridge that gap, whether that gap is that they need to lower cost, or they need to increase performance, or they have a thing that they want to make and they're still just looking for people to help them. Does that answer your question?
Yeah, but it's more around sort of how long does it take to get a new customer, right? So if you're in the second bucket where you have a new capability and you're trying to pitch it to people who maybe have to think about how that might work and have to learn more about it, and maybe you do some prototyping to teach them, then the sales cycle is a lot longer to get somebody on board. So I'm sort of curious about the sales cycle timeline as well.
So, this week alone, I've gotten a couple of RFQs for parts made to print. They showed up on a door. One of them was some bronze castings that require some machine work. And in the conversation with that customer, I said, well, why are you going out and doing these castings? We could just laser weld them into existence. So yes, we will gladly take that casting and machine to finish it for you, and that gets that relationship going. But at the same time, I'm having the conversation with them about the pilot project, and now that's a couple of months, honestly. Go from here's a concept piece to put in their hands to show them that we can essentially take two independent pieces of their supply chain, two different vendors, and consolidate that into one part process. So we kind of have this unfair advantage in the sense that we do have this CNC machine shop. When people do just come looking for generic CNC capabilities, that's our opportunity to get a good look at what they're doing, get a good look at their needs, and then say, hey, by the way, over here on the side, we have all these other applications we can expose them to, show them, and introduce. So that helps shorten that sales.
Okay, thank you.
Jesse, I just had a brief question. Maybe you covered this in here and I might have missed it. But can your technology also work for structures, rather than parts? Like, could it be used for manufacturing components for building structures?
So I guess it sounds like what you're referring to is mold tools. So mold tools are often used to build other things. Is that what you have in mind?
No, I meant whether anything that you produce could be used, to build like a building or a makeshift kind of shelter or components of that, like gates or doors or anything like that.
I don't think that's a good use of the technology.
Okay.
We do have CNCs that can cut parts up to and do this hybrid process with parts that are roughly 4 feet by 2 feet by 2 feet. So we can build up into that size. But this is not the process you want to use to make building construction materials. That would be more along the lines of maybe making a mold tool or extrusion die to then go and process polymers of materials that would then be used to make those components for fabrication.
Okay. Understood. Thanks. I believe that's all the time we have, but Jesse, if you would leave your contact info in the chat, that would be amazing. So if anybody wants to get in touch, learn more, they can do so. And with that, thank you. And with that, we will move on to our final presentation of the day, which is Macrovay. And we have Francois here to present.
Yes, good afternoon, everybody. My name is Francois van Mever. I'm actually sitting in for our Director of Business Development. So I am personally responsible for all the software that operates our systems. So I can probably answer any technical questions and know a little bit about the business side, but there might be a chance that I might have to defer the answer to a little bit later on. So let me just share. Let's go start it here. Okay. There we go. Okay, good. Company is called Macrovay, and we're basically in the business of moving stuff. So all our focus, all our systems, everything that we have in place is trying to get product closer to the point of either end consumption or consumption. And we have several different systems, which we go in a little bit later on, that we use to try to accomplish. Can you hear me? Oh, okay, good. So just a little bit about Macrovay. Been in the business of material handling for about 40 years. Do a lot of installations for Amazon, FedEx, Walmart as it pertains to both electrical and mechanical systems. We also design and build these advanced robotic systems that try to fill these crucial gaps in the material handling process. So what our area of focus is the little spot between the end of manufacturing and the beginning of the logistics process. So let's go ahead and go to the next slide. Okay, so traditionally from manufacturing goes to warehousing, then it goes into the logistics channel and gets shipped out. So that channel by itself has a lot of challenges in it. So with our autonomous deployment system, we try to create that bridge between the final step of production and the first mile of logistics. So all our systems are based on either we kit and produce the final kit or assembly right when the product gets inducted, and we do this all in a mobile situation, or we actually, in the step before a product is completed in the manufacturing process, we will actually insert assembly in order to then put a fully put together product into the logistics channel and move it out. So for example, I'm sorry. Nope, yep, we're good here. Okay, good. So it's really in that manufacturing to logistics step that we do the final kitting and the assembly required, if it is required, because sometimes we will just induct the product and then do the kitting inside the system. And at the bottom left-hand corner, you can see an image where we're using 6-axis robotic arms on rails that will actually pick products from the bin and kit the orders. And then, if required, we can move those bins into either trailers or containers that then act as their own little warehouse unit so that the operator can get to the opening, punches in the materials that are required, and the AGVs will bring that particular bin with that product to the front of the trailer or container. So for example, that last item that I mentioned, we use that heavily in the construction industry because material management on a construction site is a nightmare for a lot of people. So they actually use not the whole mobile warehouse, but they will just either use the container or the trailer to manage local inventory at a construction site. Here we have a use case where we do step into the last step of manufacturing, where we actually do autonomous assembly of drones. So we actually kit the parts in the factory. They are then moved into the assembly process. And after verification, the fully assembled drone plus its maintenance parts are shipped into the logistics channel. They go into a trailer and are deployed, in this case, to a field where they're going to be operated from. Okay, so just some key capabilities to go over. Seamless manufacturing to logistics handoff, if we need to implement that, because we can step in that last piece of the manufacturing. We kind of bypass the whole warehousing because we warehouse it mobily so that it directly can go to the final place of consumption. And sometimes even the mobile warehouses are used in cases where a company has 2 or 3 large distribution centers throughout the country, but they want to have smaller quantities of inventory closer to their local markets. So they just ship product to the mobile warehouse. The mobile warehouse inducts it. The mobile warehouse is completely capable of processing orders and kitting orders, and they are then delivered. So really everything in the system, as you can see, is handled by the robots. But before we actually even send any missions to the robots, we do a lot of pre-processing of the information that we have in the system using a lot of machine learning and or AI. Now, just a little word about the AI that we use. We really don't trust the AI. The AI is only for supporting purposes. We actually still control the decision process in the control layer, except for one area, and that is where we have the installation running in a facility where we need to place breads in trays. So just imagine big bakery brings everything to a distribution center. We've all seen bread trays, you know, when we go to the supermarket and there's a guy filling up, he's got like 17 trays and they're all filled with bread. Well, we specialize one of these components where we actually use it for orders that have mixed products. And there we use, it's called the CPET algorithm, where we actually allow it to make its own decisions in placing products into bread bins. But otherwise, our AI is only used for a supporting role. Okay. Unified throughput throughout the whole system. Very predictive operations because, again, we do a lot of machine learning before we even handle any orders. And it is extremely flexible to be deployed because most of it is mobile. I mean, even the mobile warehouse, which is 2 trailers next to each other, it's 700 square feet. And if you need to move it, you just pull it with a truck to the location you want it. This is the information for our Director of Business Development. I will share this in the chat. And if there's any questions.
Great. Thank you so much, Francois, opening the floor to questions. This is the last presentation, so it's the last opportunity for anybody to ask anything, if you'd like. So again, as a reminder, the way you'd ask questions is clicking on React, raising your hand virtually, and then we'll call you in the order of hands raised. Marissa?
Where do you get the training data for the AI?
Excellent question. Love it. Okay, a lot of simulation and historical. Okay, so there's 4 or 5 different machine learning technologies that we use. So of course, a lot of it is based on previous history. And we augment that with, we kind of have several models that will actually generate data so that we can see the outcome. So for example, on demand prediction, where we actually use it to see if the products that are inducted into the system are going to be best sellers for the next couple of batches of orders. And then we use that demand prediction to actually place the bins as close to the staging table as possible. Okay. Now, for demand prediction, we use things such as price perception, where we actually do a little research online to see what people are saying and how they are rating a product, the cost, and the cost of shipping. Okay, so we try to limit the amount of input and just kind of keep running it. And if it comes out with, we actually use the sigmoid function there to actually just get a yes or no answer. And if it does come out and say, hey, it's gonna be a bestseller, then we don't assume that immediately. We do verify that, because simple example, if you only have 100 SKUs and 100 SKUs you sell socks, and you kind of know that your white socks are your best seller, it's not going to take AI to find out and tell you that white is going to be the best seller.
Yeah.
Okay, so we kind of balance that between the products coming in and the products going out.
Mhm. Thank you.
You're welcome.
And Lisa?
So Francois, you probably won't get quite as excited about my question,
I don't
but that's
know.
okay. No. So on your on-demand kitting, you mentioned a couple of things. You said medical, pharma, and humanitarian aid. Is pharma part of humanitarian aid? And if it's not, where would there be applications for on-demand kitting of pharma?
Okay, so we're actually, right now, we're in the process of implementing a one of these for an online pharmacy in Arizona. Okay, and there, because the whole system is very modular. Okay, so in theory, you can have one arm, a bunch of AGVs, and let's say 10 bins in a rack. We don't have to do a big system. We can go very small. So for example, in the pharma one, they actually have a specific robot that actually does the picking of the pharmaceuticals into a specific little bin that then later on gets packaged. So we know that the 6 pills that are in that particular bin, we need to pick them up. We need to sort that. And in this case, we actually need to put it in a bagger after we move it, put it in a bagger, seal the bag, print the patient's name on it, and then drop it. And it goes through a little conveyor where it is processed further.
Thank you.
And you're welcome. And of course, all these arms, the key is the end effector. So it's, depending on the product we need to move, or depending on the product that we need to manipulate, it's all these end effectors that nowadays are available. You can pretty much pick up anything.
Awesome. Well, thank you so much, Francois. Please leave your contact information or Matt's contact information in the chat.
Yes,
so people know where to reach Macrovay. And that was our final presentation. So we ended, right on time, actually, when we were scheduled to end. So thank you to all the companies who pitched their really interesting and innovative solutions. And thank you so much to the panelists for taking the time to watch these presentations, engage in these, and for those who are following up with the companies, for taking the time for that. Really appreciate everyone involved with this event. And I'll be sending out a follow-up, with the recording and some of these pitch decks for the panelists. Likely either by the end of this week or beginning of next week. So you can keep an eye out for that. And yeah, wish you everybody a great rest of your day and great weekend. Maybe an early wish for a great weekend. So yeah, thanks again, everybody. And hope to see you in our future events.
Bye.
Thank you, Brian.
Thank you. Bye.